Hello, math humans. We're going to do PreCalc 1.2 today. We're going to be talking about graphs of equations and symmetry. Our objectives are that we're going to sketch graphs of equations using a variety of methods, and then we're going to calculate symmetry algebraically. So there's several different ways or methods that we can use to graph an equation. So number one, I could plot points. And in earlier math, this was often what you did. You made a T-chart that had X's and Y's, and then you plotted those individual coordinates on a graph, and that would be how you constructed a graph, and then you connect the dots. We can also do this in our calculator, which is kind of what we did with regression. We just told it lots of different points to use. The second method that we can do is we can graph y equals mx plus b, which is the slope-intercept form of a line. Okay, remember that m represents the slope, which is rise over run, which is the change in y's over the change in x's, and then b is going to be the y-intercept. Okay, and then 2 points define a line, so you connect the points and then you graph. The next method is going to be graphing by intercepts. This is actually a really nice way to be able to graph, especially if an equation is not in this form. I can just solve for x and y, and 2 points define a line, and then I could connect the 2 points. The x-intercept is when y is equal to 0, and the y-intercept is when x is equal to 0. And then the last one is using your grapher. Yay, hallelujah, we like using our graphers. The only issue with a grapher is that your equation has to be in terms of y equals. You can also use a graphing program called Desmos, and Desmos doesn't care what you put equals, and then it will graph it. This is not allowed on standardized tests. This is going to be our primary focus. All right, so let's just start off with an example. So our first example, so example number 1, we're going to do y is equal to 7 minus 3x. It's not quite in slope-intercept form, so I'm going to rearrange it, because if it looks like we expect it to, we tend to make less mistakes. So I'm going to start by, I'm going to do just the first quadrant because I think that's all I need to show. The y-intercept is 7, so 1, 2, 3, 4, 5, 6, 7. When we graph, and the graph is our work, we have to make sure that we show that. You have to label at least 1 point on each axis or the points that are relevant. So then for my slope, I'm going to go down 3, 1, 2, 3, and over 1. There are my 2 points. A little bit crappy. And there's my line. So you've done this for a long time, so that's really pretty easy. Now let's do the same equation in our grapher. So I'm going to put mine right there because you see it better. I'm going to go back and turn all of my scatter plots off because it screws up my calculator if it's still in scatter plot form. And I'm just going to enter the equation, which was a negative 3x plus 7. And I'm going to do a zoom 6. So when you're using your grapher, zoom 6 is your best friend because it resets your calculator and puts it in a standard viewing window. And it just is a lovely way of resetting the window on your calculator, right? Zoom 6 is almost a habit for me. I do it almost every time I graph. And so then you can see there's our handy dandy. The 7 would be up here, and then my slope, and there's my line. Okay. Now let's do the same problem using intercepts. So I did it with algebra, and I did the slope-intercept form, which is the easiest way to graph a line. And then now I did it in my grapher, so that was method 2. Method 3, I'm going to do by intercepts. So I'm just going to write the equation again so we have it handy, 3x plus 7. Remember that my x-intercept means I let y equal 0 and I solve. So I'm going to get 0 is equal to a negative 3x plus 7, and negative 3x is a negative 7, x is 7/3. Okay, and you can't see that, my bad. Okay, x is equal to 7/3. When we report intercepts, because it is a specific point, you have to report them in ordered pair notation. So the x-intercept would be 7/3, 0. When I find my y-intercept, that's when x is equal to 0. So then I would get y is equal to a negative 3 times 0 plus 7, or y is equal to 7. And then I report that the y-intercept is at 0, 7. And if I hadn't already graphed this, if I was graphing using intercepts, I would go to 7/3, and I would label it, and I would go to 7, and I would label it, and then I would connect my dots, and that would be graphing by intercepts. So you need to make sure on a test that you use the method that's asked for. We also need to make sure that when we are graphing and showing lines as part of our work, that my preference is you put at least an arrow on a vertical and a horizontal axis, and that the points that are important are labeled. All right, so now let's move on to our second example. So example number 2, we are going to find x and y-intercepts, and then our equation is f of x is equal to x cubed minus 4x. So this is a nonlinear equation because I have a third degree, but the process is exactly the same. For the x-intercept, I let y equal 0, so I'm going to get 0 is equal to x cubed minus 4x. Factoring is your favorite F word, so I'm going to solve by factoring, and I get x squared minus 4, and then that is a difference of 2 squares, so I get x plus 2, oops, bad math, and x minus 2. And these generate 3 solutions. Third degree, 3 solutions. X is equal to 0, a negative 2, and a 2. So I would report that as x equals 0 and plus or minus 2. But remember, when I report an x-intercept, I am supposed to write it as x-intercept, and then colon. I'm going to have 0, 0, and then I'm going to have 2, 0, and then I'm going to have a negative 2, 0. Those are the 3 x-intercepts. The y-intercept is when x is 0. Well, if x is 0, hallelujah, the math is easy. So y is going to equal 0 cubed minus 4 times 0, which is a big fat 0. So then the y-intercept is going to be the origin 0, 0. So that was pretty easy. The next thing that we want to talk about is symmetry. And in geometry, you learned a lot about symmetry. In math, we're really only interested in 3 different types of symmetry. There's lots of different types of symmetry. The first that we're interested in is about the y-axis. So I'm going to write about the y-axis. And a great example of that is a parabola whose vertex is at the origin, and it is symmetric about the y-axis. The other one that we care about is symmetry about the x-axis. And the classic example for that is going to be the square root function that looks like that. So this particular graph is symmetric about the x-axis. The last one that we care about for math is about the origin. And that is rotational symmetry. It's a 180-degree rotation about the origin. And the classic example is going to be the cubic function. And if you think about, if you put one of those little brads there like you did when you were in elementary school and you bent the little arms back, and so you had 2 different arms, and you rotated this arm would rotate around and map on top of that arm, which would be 180 degrees of rotation. So that's what symmetry is about the origin. Okay? One of the things that I want to talk about is, let's say I chose a point here, x, notice that x is positive and y is positive. If I reflect it across this axis, now x is negative and y is positive. Okay? Alrighty? So the y's stayed the same. Alright? That's important to notice. On this one, if this is my x, I have a positive y and a negative y for the exact same value of x. And then if I get in this one, if I had a value for x, it has a positive y. But when I get over here, I have a negative x and a negative y. So in symmetry about the y-axis, the y values are both positive. I'm going to change that plus to a y. In this one, I have a plus and a minus y. And in this one, I have a positive y and a negative y. So now let's talk about what that looks like for the algebraic test for symmetry. All right, so we're going to be able to do this not only graphically, but we're also going to be able to do it algebraically. So when I want to do an algebraic test, I'm going to evaluate the function at a negative x, okay, and then I'm going to manage the results. If I evaluate the function at a negative x and I get the original function, okay, I'm going to write this as the original function. That means everything is the same, then this is symmetric about the y-axis. If I manage a negative x and every sign is the complete opposite, then this is symmetric about the origin. Okay, that means that every value in the equation is the exact opposite, then that is symmetric about the origin. And then the last one is kind of a weird situation. If I had an equation that looked like y squared is equal to x, and I wanted to solve for y, I would get y is equal to plus or minus the square root of x. This is your key that it's going to be symmetric about the x-axis. All right, so that's how you manage it algebraically. So now we're going to do some examples. All right, let me go to another sheet of paper. So our third example is going to say test for symmetry algebraically. All right, and our equation is going to be y is equal to 2x cubed. So the test is really very simple. I do the same test all the time. So when I run the test, I'm going to do f of a negative x, which means I substitute that value into the equation. And when I do 3 negatives is a negative, I'm going to use negative 2x cubed. So this says that when I did this math, every sign was the exact opposite. And there's only one term, so that was a pretty easy. Therefore, those 3 little dots mean therefore, this is symmetric about the origin. And if you were to put it in your grapher and graph it, right, 2x cubed is just a steeper, and so it might look like that. And that is indeed symmetric about the origin. Okay? All right, let's do another example. We'll do example number 4, and it says the same thing. So I'm not going to rewrite the directions. We're still going to test for symmetry algebraically. This time our equation is going to be a little bit more entertaining. It's 2x squared minus 3x plus 5. And the test is the same. There's only one test. So I'm going to run a negative x through the function. So this is 2 times the negative x squared minus 3 times the negative x plus 5. So this is a negative squared is positive 2x squared plus 3x plus 5. Now let's compare the new equation and the old equation. these two terms are the same. These two terms have an opposite sign, sad day, and these two terms are the same. So it's neither all the same nor all different. So therefore, love therefore, this is neither type of symmetry. Brain and hand aren't working at the same speed. Alrighty? If you graphed this particular graph in your grapher and looked at it, it would look kind of like this, because I've done this in my grapher ahead of time. There's the little vertex. So this is not symmetric about the y-axis. It's symmetric about the vertex, but it's not symmetric about the y-axis, therefore, neither type of symmetry. Alrighty, that is it for today.